I'm Geoff, and I'm an engineer working on our AR efforts over at Google on a team specifically focusing on making the developer experience for AR and VR awesome. I'm really excited today to talk to you about ARCore and the developer preview and how you can easily make AR experience for Android using Unity. So in this talk, I'll be covering specifically AR and its relation to the very related field of VR, the concepts underpinning ARCore, a brief overview of how to get set up with ARCore in Unity, and finally, tips and best practices for making AR great in Unity. Since there's already been a lot of ARCore talks, and AR talks in general, I suspect some of this information will be repeated, but a lot of it should be new. And can I get a quick show of hands on how many people have actually tried using ARCore with Unity so far? Great, that's actually more than I expected. So first, AR and VR. I'm sure many of you are very familiar with AR and VR, but I want to take a moment and talk about how we think of this as a kind of a shared space when we build our platforms and experiences at Google. So AR and VR together make immersive computing. So rather than thinking of AR and VR as completely independent technologies, we think of them being as two options within the spectrum of immersive computing. On the far left of the spectrum, we've got the real world, reality, life as we know it. And if we start adding digital content to the real world, we end up with augmented reality. And finally, if we replace everything with the virtual, we have virtual reality. And different devices and platforms will kind of fit at different points along the spectrum, such as heads-up displays versus just using your phone for AR. With VR, we think of it as having the ability to take you anywhere. So you replace everything with digital content, and you've got VR, which lets you visit places and worlds in an instant. And some of the benefits of VR, or other technologies, are complete immersion. You really feel like you've been transported to another place, especially as the hardware gets better and better. And also, there's been huge innovations in input, which allows you to work naturally within VR, doing gestures and things you couldn't do otherwise. AR, on the other hand, can bring any of your digital content into the everyday world. Here you can see us bring a lion into a scene with a dog, and you can composite tons of virtual content with the real world. So some of the benefits we see with AR are you can see objects at a real size and scale in your world. So imagine buying furniture for your house and seeing how it look and fit within your space. You can see things in context, which could be writing notes to yourself, which appear within the real world and are persistent next time you're in space. And finally, natural input into seeing. We see it as a way of natural input into seeing complex 3D objects. So instead of doing difficult camera maneuvers, you just use your phone, and you can get up right up close to a 3D asset. So immersive computing is the future. Both VR and AR enable us to experience computing more likely to experience the real world, and both take advantage of many of the very same technologies. With Cardboard, Daydream, and Tango at Google, we've been invested in this space for quite some time, and we really believe that interacting with your data in a more natural way is the future. Immersive computing removes more of the abstractions between us and our data. So with the overview of immersive computing spectrum, I'm going to talk about now some of the background that went into building ARCore on Android. So Android is a huge platform. It's the biggest mobile computing platform with 2 billion devices out there. With AR maturing, we would love if as many of those devices as possible become AR capable. Since Android was launched in 2008, about a decade ago, mobile devices have changed a ton. We've had integrated fingerprint scanners, newer touch interfaces, voice-capable assistants, and among other things. And we think AR marks the next big shift in what's possible with mobile devices. So imagine taking a walkthrough of a car you've been thinking of buying without even having to go to the dealership, changing the color model, seeing every customization option, which you can't normally do at the dealer, or just playing a game where the environment actually becomes the play space, or even exploring a museum and having the paintings come to life. We've been developing AR tech at Google for a very long time. Well, in AR and VR timeline. It's been over 3 years since we launched Tango with the idea that your devices should be able to understand more about the world. Tango used dedicated hardware and allowed us to understand depth, reconstruct the world around us, and support full tracking using only mobile hardware. With this technology, we built 2 consumer devices with Asus and Lenovo, and developers were able to create over 100 apps using Tango. They range from an app to measure your world, to get exportable scanned mesh data of a space, or just playing games with characters that can navigate the real world while avoiding obstacles. We've learned a ton since then, and we've improved our software stack to the point that we don't need dedicated hardware for AR anymore, which leads us into ARCore. So in August, we announced ARCore, a preview SDK for now that allows us to get you to get up and running with building AR apps right now. ARCore takes everything we learned from Tango to make AR available on your phone you have today. No special sensors required. ARCore is currently in preview, and this is a great chance to get a jump start on building with the technology, as well as a great time to give feedback so we can make ARCore as great as possible for you. So I'm going to talk a little bit about the ARCore fundamental concepts. This was briefly covered in the keynote and a few other presentations, but I'm going to flesh out specifically how ARCore handles some of the core AR components. The 3 fundamental concepts are motion tracking, environmental understanding, and light estimation. So first, motion tracking. To render AR content, you need a virtual camera that matches your physical camera, i.e., when you move your phone, your camera moves with you. The idea would be that you render the virtual scene, composite it on top of your camera feed, and you're done. Sounds easy, right? It turns out making your virtual camera match the phone's position in the real world is a really, really hard problem, as we've seen with how long it's taken to get it good on mobile. While phone gyroscopes are great for pure rotation, phone gyroscope you have on your phone today, they drift over time, and accelerometers, which we also have on our phone today, are great at acceleration, but they are really bad for precisely tracking position. The really hard part of getting AR right is to figure out how the translation and rotation of your device work in real time. If you get this wrong, objects in the world are misaligned, swim, and jump, and don't appear properly rotated to the real world. I'm sure you've seen plenty of bad AR experiences out there when something goes wrong. But when this works correctly, it creates a really fantastic experience. As you can see in the GIF of the scarecrow, when you actually move the camera to match the real scene, objects can look like they're really fluidly within the scene. Obviously, this isn't the most realistic asset, but if you get more realistic assets, oftentimes people can have trouble distinguishing between the real world and your composited assets. So to do this, ARCore uses the device's camera and inertial measurement unit, or IMU, together to track correctly where your device is in the world using a process called concurrent odometry and mapping, or COM. It looks for visually distinct feature points that it can track over successive frames and build a point cloud from that, which it can then localize against. We call these points feature points, and these, combined with the IMU's acceleration and position data, gives you rotation and translation of the world so you can render your virtual content in the right place. So this illustration shows a little bit of how things kind of work. Those 4 points over there, you can think of as feature points. Obviously, with the real tech, we have way more feature points than that. And using the API, you can actually see the feature points within your app when you're developing. And you can see the trail that the phone makes. So since we're tracking your position in real time, that's kind of how the AR components work, is your virtual camera in the scene can move along with the real world through both rotation and translation. Next up is environmental understanding. So just showing and navigating the world isn't quite enough, since you still can't really place any objects in it, you can't really interact with it. So through our API, we try to provide access to the feature points directly, which you can hit test against or help to use visualize the space. And additionally, when ARCore sees clusters of these points that appear on a common horizontal surface, it makes these surfaces available to your app as planes. Since planes are actually infinite, ARCore also provides the bounds of these surfaces as either a polygon or rectangle. You can see this information, you can use this information to anchor virtual objects onto real-world surfaces, as you can see in the GIF up there. And here's an example of us finding multiple surfaces. Planes are detected on any horizontal surface, such as floor, tables, desks, chairs, seats. My favorite example is you can actually use a laptop keyboard a lot of the time, and that will just be detected as an independent plane. And planes will continue to appear as the session goes on, so we're actively trying to find planes every single frame as we update. One small word of caution, though, not all surfaces are great for plane finding today, particularly very uniform surfaces or very reflective or plane surfaces are a little bit hard to detect today, but it's something continuously being worked on. And the third and final concept with ARCore is light estimation. So ARCore captures information about the current environment's lighting and gives it back to you as a value representing the average intensity of lighting of a given camera image. What this means is that you can actually use this value to get the light on your virtual objects to match the real-world lighting conditions, which it greatly increases the sense of realism. Objects can look very out of place when you don't have proper lighting. So imagine a table that's fully lit appearing in a very dark room. It just does not look particularly good. Additionally, you can actually even use this lighting estimation API to have your scene react to lighting conditions. For example, you see in this GIF, when we turn the light off, the lion gets scared. So this is a part of an actual demo we've shown previously that works pretty well. And it may not seem like an important detail compared to the other two, but proper light estimation is essential to getting your experience to feel immersive no matter what environment you're in. So I highly recommend paying close attention to it. So right now, ARCore developer preview runs on the Pixel, Pixel XL, and S8, running Android N or above. In the future, it'll run on specifically qualified devices, so not every device is AR capable, but we try to make as many as we can AR capable. And by the end of the preview phase, when we actually launch ARCore, it will be running on 100 million devices. And we're working with several manufacturers, including Samsung, Huawei, Asus, LG, to get it on all their Android devices. So we provide, as part of our SDK, interfaces for Unity, Java, and Unreal, with the thought being that it shouldn't really matter what you develop for. The API should just work and be similar. And I'm going to take a brief pause here and talk about the potential of Unity specifically for developing in AR space. So one thing very different about building for AR compared to traditional applications is the set of requirements to make a great experience. Rendering virtual objects, high performance requirements, responsive interface, access 3D environments are really well suited for existing game engines today, as I'm sure you're very aware. So traditional app developers are actually not quite as well set up for this because most environments don't really build to 3D. So even though I'm sure most of you are probably game developers, if you ever had an interest in application development, this might be a very good opportunity to jump on that, since this is a space you are probably all close to experts in that normal app developers can't go for. And on to ARCore specifically in Unity. So we have a nice developer link there, which I can never memorize. So I always just Google ARCore Unity, and it comes up with our Getting Started guide. So I'm going to go over the basic setup of how you get ARCore working with Unity, and then I'll go on to some more specific tips and tricks. But most of the information I'm going to give on the setup you can also find in our guide. So assuming you do have a AR-compatible phone of the subset I mentioned, if you've ever done any Android development for Unity, you're actually most of the way there. You're done with this whole slide setup. But since it isn't really any different for ARCore, but to get set up, you do need specific versions of Unity. Right now, that's 2017.2 beta 11 or higher, and 27.3 beta 4 or higher. Obviously, the full releases of these will also work great. For example, I've been using the release candidate for 2017.2. And with these tools in place, you just need to get developer options turned on your phone, USB debugging, and if you've already worked with Android before, you've already done this. And then the last thing you need is the ARCore service. It doesn't actually come as part of Android currently, so you'll need to download it from our website and just get it pushed onto your device. And next up is actually building your Unity app with ARCore. So these steps can be done on either a new or existing project. I've actually found that VR projects are already very close to being set up for AR. So once you've opened or created your project, you'll need to install our .unity package, which can be found on our website. And this gives you all the scripts and prefabs you'll need to work with ARCore. To configure AR-specific project settings, you'll first need to switch your build target to Android. And we'll help you build your project. So now, onto the actual settings you need to configure. We just have a few specific things you need to turn on. They're pretty simple. You can just go to Edit Project Settings Player to get access to these. We don't support multi-threaded rendering currently. You'll need to actually set a custom package name if you're working from scratch. Then you just need to set your minimum API level to Android N, or API level 24. And then finally, under Publishing Settings, again in Player Settings, just turn on, or sorry, XR Settings. Just turn on ARCore Supported. And your project is good to go. And again, if you do grab the Unity package from our website, we have a sample scene which has everything already set up for you, other than the project settings. And this is our sample scene. Very simple, very straightforward. So I'm going to talk a little bit about the basics of the API within Unity. This is more tailored towards programmers, but even if you're not a programmer, knowing these basic concepts is going to be pretty valuable. So we give access to most things through to most of the API through the frame class. You can just grab tracking state, planes, feature points, the current light estimation data, and then you can use the session class. You can both access all these statically to create anchors or just raycast into your scene. And then finally, the tracked browse driver, which is provided by Unity, works for both VR and AR, is used to synchronize your scene camera with your phone's motion. So if you do want to set up your scene to be AR ready, again, our example covers this, but our example already has this set up for you. But you'll just need to get an ARCore device prefab in your scene, which we provide in the API. You set the update type to before render. If it is already set to that, but it's important to call out that before render just makes it so that as your frame is rendering, your camera is completely in lockstep, so you don't have any delay in your virtual objects compositing. And in addition, if you do plan to do any effects like dragging objects where you want it to real-time update with the camera, make sure you do that on pre-render instead of the normal update. Otherwise, you will have a frame delay with that, which does look kind of jittery. And then the last thing you need to do is just place your environmental light prefab in your scene, which allows ARCore's ambient light data to be accessed by the shaders. So I'm going to talk a little bit about anchors. Anchors are what we recommend you use to place virtual objects into your scene. They basically have positioning data about where the object is that goes beyond the global coordinate system. So if we notice like that a drift correction needs to be made on, like say half of your world space, whereas not the other half, if you have anchors, we can actually correct the positions of the anchors. Whereas if you just did things in global coordinates, half your scene might be a little bit skewed. So for using anchors, they're pretty simple. You want to use them for drift correction. What you want to do is you'll actually want to create an anchor with the specific point that you want to store. And then as you move your objects, if you do move your objects around the scene, try to replace their anchors with new ones as you need to. And it's important to route your digital objects to physical objects in the world because otherwise users don't really have a good point of reference. And then finally, global coordinate systems, they're fantastic. They make life easy. Try to use anchors. So for plane detection and the plane API, one thing important in your app is, this is just a general development concern. It's not really API specific, but choosing between single or multi-plane experience can make a huge difference within your app. A lot of the early AR experiences that have been released on various stores or in demos actually end up being single plane. As it turns out, having a really good multi-plane experience today is kind of an unsolved UX problem. How do you drag things between planes? What do you do if a plane's not detected? So in many ways, it can be simpler just to have a single plane experience if you're just willing to use the floor. And if you do want to move between planes, then that's also something you can easily do. You just want to be very cognizant of it when you're making your game or app. Other things to note, planes can take time to be detected, and especially for UX concerns, in terms of UX concerns, you may want to prompt your users to actually go detect them. So I might be standing far away from this table, not falling off the edge, and then hoping that my plane will be detected. But if I'm too far away, it might never happen. So it's important to let users know that they might have to do something active in order to actually get a plane detected. And this applies to all current AR APIs. And something very simple way to use our API, frame.getAllPlanes. It tells you what all the current actively in place planes are. You can also use frame.getNewPlanes, which will give you only the planes that were newly detected. And you can also access them through session.raycast. It turns out most of the stuff you want to do is actually on top of either surfaces or other objects. So raycasting into the scene to actually place things is generally the simplest way. I found when I'm developing AR experiences, I don't really use the planes directly all that much, unless I'm trying to render them. So rendering assets. Again, light estimation, really important. So we've provided a set of shaders you can use that have lighting estimation support, but implementing it yourself is also quite easy. I recommend using mobile shaders whenever possible, or just in general really lightweight shaders. Hitting a stable 60 or 30 FPS can make your app feel so much smoother. This was maybe less important in AR than VR, but still very, very critical. And even when your camera isn't necessarily updating at the same frame rate, making your objects feel very smooth makes a much better experience. Also, tips and tricks you can use. Since right now, most of the lighting information is just a single brightness value, you can actually get away with a lot of times with baked shadows, baked ambient occlusion, a lot of baking, and you can really get extra performance out of your virtual objects. One thing also, just as a side note worth noting, scenes are generally cheaper than in VR or even other general mobile 3D experiences, just because it turns out you don't have to render a lot of the screen. And if you did want to build a custom shader, it's very easy. We have this global light estimation value in your scene, which will contain a value from 0 to 1. And all you have to do is multiply your final color by this to get our ambient lighting to work. And you can see in the surface shader, it's as simple as adding a final color pass, which will multiply it. In a fragment shader, it's equally easy. You just multiply the color. And I'm going to briefly talk about one of the tools we've introduced around the same time as ARCore is blocks. It's not specifically meant for making AR content, but what we found is it's really nice since it's a VR experience where you can build polygonal models. It's really nice for just rapidly getting assets in there. And in fact, some of the demos we've used ourselves end up using blocks assets. We also have a booth downstairs you can check out if you're interested. Another thing I want to briefly mention on is WebXR. So right now, Unity can target the web, but there aren't really any AR experiences really ready today that can target the web. So we've built an experimental browser that is AR capable. Right now, Unity can't target it. Obviously, this should change in the future. But it's something to keep in mind that AR experiences don't just have to be full applications. In theory, we should be able to make a very lightweight mobile experience that works. And here's our developer website. It's just developers.google.com/AR. That contains a lot of the information I've talked about today, and general good ways to get set up. And also, if you are interested in developing for ARCore, we have a coding lab session that we're running both. I think it's probably done for today, but it'll be running again tomorrow, starting at 10 a.m. So if you don't have a Pixel or other AR device or other ARCore capable device, we do have phones for you that you can use. All you need to do is bring your own laptop, and we'll help you get set up with Unity, our development environment, and help you out with any issues you have. And this is drop in, drop out, so you can come in at any time. And then as well, me and other Googlers will be available to answer questions. And that is floor 4, room 18B. Oh, and I have a brief video, if it loads. So that is ARCore. Thanks. And if you have any questions, please use microphones.
Assume walls are just way harder than floors, and that's not something we can deal with.
Walls are way harder than floors. It turns out with horizontal surfaces, you have the advantage of gravity, which means you always actually know your normal that you're looking for of the wall. And with verticals, you don't get that. That being said, vertical walls are obviously something that's being actively worked on.
One big thing for us is like we're trying to develop an app that would be cross-platform, so iOS and Android, and obviously this wouldn't run on iOS, right? So did you guys keep in mind how that would be possible? For instance, I don't know, using ARKit on iOS, using ARCore on Android?
Yeah, so Unity is doing quite a bit to make that as easy as possible. In addition, the APIs are actually very similar. They've got a few differences, but if you're targeting one, it's relatively easy to try to target both. But I do think Unity is going to be pushing more and more from what I've heard.
Thanks.
Mm-hmm. All right, no more questions? All right, thanks everyone.